Let's have a look at methods from an abstract point of view in the sense of what's going on inside our computer when all these methods are doing their thing. So here's our computer. And when we run our program, so when we press the little play button, we can imagine that there's a little man inside our computer, and we'll call him Computer Joe. And he responds to that play button of the running of the program. And then he waits for an event to happen, such as a button click. And the button click has a method. So instead of Computer Joe running the code inside that button click method, he calls the button click method guy to execute that code. So he's responsible for that. So button click declares the variables that need to be declared. And if we again think back to our f equals ma example, we wrote a method to calculate the force. So when that method was called, that is not button click's job, that's calculate force's job. So he calls calculate force, which is another little guy living inside the computer, and I really can't draw. And so he does that calculate force code, and when he calculates the force, he returns the flow of control to the button click and returns any values that he's calculated that he was told to return. In our case was the double, and the code continues on. And one of the things that I mentioned about methods is that they make code reusable. So for example, this was our kind of form 1, and this is just to paint a picture, because at this point you're not going to be writing other programs that are calling or other classes or anything that are calling methods, but just to paint the picture of what's going on. You could technically write another kind of program. I don't know what it would be, we'll call it form 2, in which there's, say, Computer Jane, and if she needs to calculate the force, instead of having her own method, she could just call the calculate force method from, I guess we'll call it form 1. And you're kind of doing that even though you're not writing something else. You're doing the calls. For example, you're using the toString method, so you can imagine that there's another form here called convert, and convert has an employee that is responsible for converting things to string. So button click, when he has to convert something to a string to output it back into the text box, he'll call the toString method. And in here there's also toDouble, so when he's first taking something out of a text box and converting it to a double, he calls the toDouble method from convert. So it's a big large party going on inside your computer where nobody likes to do a lot of work and they just like to pass the job around. The nice thing about that is when you're writing your algorithms, your methods are kind of packages for those algorithms. So instead of having Computer Joe or button click, I guess, responsible for this big mess of code that's going on, you can just package it up into little packages, pass on the responsibility to all the other people inside the computer, and together they make your program work. It also makes things easier to debug. Definitely makes code easier to write because you can concentrate on one thing at a time instead of looking at a lot of code that's greatly interconnected, and it's really hard to keep in your head what every line of code is doing at any point in time. So you can think of the methods as little packages for your code, or little employees responsible for doing just that one job. At this point in the game, your programs are small enough that you can keep all the information in your head and be aware of what's going on everywhere. But this is the time to start using methods, because as your programs get bigger, it's really hard to keep track of where everything is going. So if you think to your lecture 2, you had an algorithm for solving the quadratic equation, and all the code was given there. So when you think about, there was a solve method, and there was a button click also. So we'll put Computer Joe back to work. The button is clicked. He calls the button click method. And button click calls the solve method. To solve the quadratic equation. So that should give you the big picture of what's going on and how the methods are the packages for your algorithms. So now it's just a matter of working through that code and understanding how it's implementing the algorithms that are given. So lecture 2 is a great place to start, and everything is given there. You have your form, and you have the method for solving the equation. You even have the code for the button click. So you can recreate that program pretty much by copying and pasting that the code that's in those lecture slides, just making sure that you name the components of your form exactly how they are in the code, and you should be able to get that up and running in a pretty short time. So hopefully that helps clear up methods. So have a visit at lecture 2 and see how that works for you.